My name's Clark Sell. As Nico said, we did have an opportunity to work together, and that was a ton of fun for sure. We are here to talk about Graph. So, and this is going to be a super interactive. We're going to look at real stuff, kind of meander through questions and whatnot, because at the end of the day, this is really for everybody that's here. It's not to kind of guess at what people would like to know. So I say that because get your questions loaded up in the Q&A, because we're going to start in on that as soon as possible. I don't know if there's a way to really raise one's hand, but I'd definitely be curious if anybody's doing anything with GraphQL or has or looked at it, just to kind of gauge where people are at. But I recognize that that's you can raise your hand, but I can't really see it. So internet. As Nico said, what's that?
Oh, Clark, I was going to say people can request and actually can ask questions live. We can actually do that. We can let them hop in and ask a question. So,
God bless.
Yeah, I'll pay attention to the chat.
As possible. Okay.
Yeah.
As Nico said, my name is Clark Sell. I do run 2 companies. Let's just kind of flip over to what is described as a messy desktop. But I do run 2 companies. It is Sell with an S. Not that anybody would confuse it. But first company, the day job, unspecified. We are a small boutique software shop. We do some consulting. We do some product development. Try to help people out where we can. I stream every morning on Twitch. You can find me at unspecified.live. That'll take you over to Twitch and where we're at. All the code and the things that we can go through today, you'll find it up on our GitHub at Hello Unspecified. So I'm in the middle of putting together actually a graph course, and we're kind of just doing it live. So if you want to see all the different pieces and bytes and all that, feel free to join or reach out, ask a question. I don't care. Company number 2, because one job's not enough. I run a company called That Conference. We are a developer-led conference. We build all of our own stuff. Excuse me. You'll find us at that.us and thatconference.com. I'm going to reference, we're going to talk about everything tonight kind of in the scope and guise of these. These are both platforms that have been built on Svelte, React, Next, GraphQL, serverless, NoSQL. You kind of name a lot of the latest buzzwords, and a lot of that's in there. Anthony, the Twitch link is unspecified.live. That's just the URL. That'll redirect you.
Yeah, we got it in there for you in the chat. And one thing too, just for everybody, we'll send out like links to all that stuff too afterwards via email for everybody. So in case you miss it, we'll follow up.
And keep them coming. Like, I don't mind being interrupted at all. I do it all day long on Twitch. So the code for that conference, that's actually at GitHub at that conference. It's all open source. You'll see everything that we're going to talk about there. If you want to email me, hello@unspecified. I'm typically CCL5 on Twitter, or that conference, and or hello unspecified. Any 3 of those, I guess, are all me, which is, now that I say it out loud, too many. And then pretty much Clark Sell everywhere else. So that's kind of a quick thing, who I am, what I do. At the end of the day, I consider myself a practitioner, and I spend most of my days and nights coding and trying to help everybody along the community. I've been doing Graph now for 4-ish years. Couple big customer implementations, and then our own from small to big, and everywhere in between. There's been a number of aha moments along the way, and I hope that throughout the next hour, 2 hours, we're able to kind of let you walk in our footsteps and not fall in them, if you will. I'm going to kick this off pretty open, in the sense that Graph is a query language for an API, not to be confused with a database. So let me pull open a really quick set of slides just to kind of get the questions rolling. Need to push this to the side so I can make sure I can see. Y'all are seeing the whole thing. So, if you see me looking this way, it's because I'm looking at the other side of the giant monitor. So, so Graph at its core is a framework, or really a spec, that was designed by Facebook and is maintained by Facebook. It has been around since 2012, I believe. It's a query language, not different than, if you've been around the programming space for a while, you may have remembered something called OData. You may have remembered something called WSDL, and some of those things were centered around trying to put some kind of safety and a contract around this notion of an API call. GraphQL is, in a sense, a query language for that puts type safety, introspection. But this really contract, like if you think of a web browser and React and how we work with the browser and the DOM, that's a contract, a visual contract and a contract to the browser. GraphQL is this contract that we're creating that's for the API and those who consume us. And I think that's important to think about it that way, because one of those aha moments for me was the fact that what this does is, in the end of the day, what we're trying to do is we're trying to describe a business model that our users can use and kind of read and tell a story and interact with. And because of that, it opens up interesting ways, and it kind of brings that business model forward a lot earlier in the conversation, because it's at the API, and thus you need to respect kind of, that wire call coming in. I don't really do slides, but 2012, you can find this spec at graphql.org. A lot of big companies are doing it. They maybe don't talk about it necessarily publicly, or like they're not shouting from the rooftops, but people I know there's people from all over the country. So Yelp might not be applicable, but even efforts like Yelp have a Graph API kind of hiding behind the scenes. But and for those that don't know what Yelp is, it's a way to find restaurants and things like that on your device. When I tend to think about frameworks, I tend to think about things like how things are being, I think about the culture and the development that's around it, right? When we take on a framework, we're taking on an opinion. We're taking that kind of into our house, into our home, such that we have to, we have to really deal with it. And thus, if we don't like that opinion, then it hampers our ability to kind of move fast or move safely, if you will. So I tend to look at these kind of attributes when I think of taking on a framework. And a lot of people will say, well, Graph is new, and the reality is it's been around for a long time. Facebook had implemented this before they'd ever even released it publicly, as a way to solve them getting off of their old API and starting to get into a bridge between their mobile and their website and everything that behemoth has. There's a great video on YouTube. I think it's called the History of Graphql, where one of the creators talks about kind of how its origin story and how it grew up. So certainly something, if you're interested, to go chase after. But so I tend to think of, who are your consumers, the tooling that's around it, how easy is it for us to work with it? The community, since it is an open source effort, even though it is backed by Facebook, we start to see things, especially like React and Vue, now Svelte. When you start to see the community center around it, we start to see interesting additions to it, interesting things that bolt on to the side and to the back and to the front, which all help us kind of move together faster. Of course, if you're using a framework and you're taking on its opinion, it better get you to market faster, because if it didn't, what's the point? We could have just made it ourselves. If you can't test it, it's kind of not a good thing. I don't know, there's lots of opinions about testing or automated testing, but for me, it's a big deal. And then plumbing and productivity, there's this balance. GraphQL certainly at its heart, it's a lot of plumbing. No different than Express is, plumbing over HTTP and Node and making your life easier with just managing a server. GraphQL at its heart is a framework to help you do plumbing to make API calls and to query against them. So the core, let's see, there's still no questions. So you got to put some questions in there. Otherwise, this is like talking into a void. And this is for you. Are we going to do a demo? Yeah, we're gonna do like 2 more of these, and then I don't want to see any more of it. At the core, what we're doing with Graph is we're going to describe our model, and then we're going to query against it, and then we need to fulfill it. Those are the 3 steps. We can describe it, we can mutate it, and then give some results that's back. So just think of it in that 3 ways. We're going to define a schema where somebody's going to call it in that way that it's been defined, and then it's going to get fulfilled. And how we fulfill it is up to us. That could be one database call, that could be many database calls, it could be other REST services, it could be other graph services. It's up to you to fulfill that to the contract that was called upon. So, Anthony, to your point, let's kill the keynote because nobody wants to see that. Great question, Robert. What I want to learn is GraphQL is the feel for using it. How is it being widely used in industry, and what kind of cutting edge? Yep. Why not Graph? Why Graph versus REST? Well, I will. Let's show a little bit of. I'm going to set up that conference where last year we were for those that don't know, that conference, you go to thatconference.com. We are thatconference.com is a physical event for software developers and their kids. It is a 3-day event where we all get together and geek out on tech and whatnot. I'm telling you that because we're going to talk about its graph endpoint, and I'm going to get into REST and where some of that stuff works, because I want to use a real thing that you have context against. We just launched another site called that.us, which you all are invited to. This is our online place. So this is where we kind of are fulfilling the other 363 days out of the year in a kind of birds of the feather, open spaces way to get together and talk about technology and whatever that's appealing to us. So this is a live thing. We just launched, I think 2 weeks ago. So all that to be said, let's talk about the business model that's behind it and kind of come forward in what we're eventually going to query and model. So as Emma says, and there isn't any reason why you can't have both. There is not any reason. And quite honestly, the reality is you will have both. I think use the right tool for the right job. It's just a different HTTP endpoint. So actually, before I get into this, let's just make a query. So here's a tool called Insomnia. If you haven't used it, it would be, I don't know, I guess a competitor to Postman. I happen to like it a little bit better. Nothing against the other one. I used the other one for a long time. In here, we have all of our kind of queries that we test and use and kind of sling back and forth. So rather than you watching me kind of beep boop on the keyboard, we're going to do some of it right straight out of here. So let's start at our simplest. If I want to just call a graph endpoint, so this is me, the client, be it a Svelte or React or whatever curl. What I'm ultimately doing is I am formulating a post. So a little different than REST, where REST is going to really lean in on the verbs, you know, your puts, posts, gets, deletes. What we're going to do from a graph side is we are going to 13-inch laptop. Oh, we got to get you. We got to send you a monitor. Hope that's a little better. Let's stretch this over. That's as big as I can go. I didn't know there was a limit on that. So ultimately what we're going to do is we are going to formulate a query or a mutation. Those are graph terms that we are going to post, make an HTTP post, and we're going to include that in the post body. You can do a get on some queries, but you can't on a mutation. And a query, as it sounds, is just an arbitrary kind of graph term that we're going to compose a statement that we're going to send to the server, and we can validate it along the way. We can validate the types along the way, and then we're going to get an answer. We're going to get an answer that fulfills what we've asked for. So if I go to my, let's go to my production site. So,
Hey, Clark.
yeah.
It's still pretty hard to read. Maybe, or is that what you're trying to do, is get to a web browser for more zoom, or should we change the resolution of your desktop perhaps?
What's hard to read right now, or Insomnia?
It's just the whole screen is just kind of a little bit blurry around the text in general.
I can't change the resolution because that it won't work. But that's quite large. Is that still hard to read?
Yeah, it just looks super compressed. I'm not sure why.
We can see it now in the browser, but it does look a little bit blurry. I'm not sure why. I think Insomnia looked hard to read, but this we can see.
I can't make Insomnia. It won't go any bigger.
Yeah, that's fine.
And I can't take a widescreen and try to make it work either. In creating a graph endpoint, what we're doing is we're defining that schema, and that schema is something that can be interrogated. It's something that we can give out as documentation. It's something that describes how it is allowed to be called. So our schema, in this case, you can also look at it visually, and I'm zooming in on purpose. Our schema on the query side is quite large. You can see that we have lots of, each of these boxes, while small, represents a type. That type has some fields on it. Those fields, in our case, what we're trying to do is we're describing an event and a speaker and a session and their location and things around how you would run a conference and how you would connect people together. So our schema, and it's is quite large given what it is. Our here we go. Our events, our root, if you will, is our events, what venues we participate with, what communities we work with, the partners, the sessions, and the members. And they're all, for us, these are all separate things that get composed. Like members is deployed separately, then sessions, and partners, then venues, excuse me, then events. They kind of disjointedly know about one another, but they can only fulfill themselves. So if you were to think of a shopping cart and an item, a shopping cart knows how to put items in it, but an item doesn't necessarily know anything about a shopping cart. It's put into a shopping cart, and those two things would probably be pretty separate in a graph world. So if I was to look, go to my endpoint, and mind you, I am, Anthony says, what tool is that? This tool here is a tool called Voyager. It's a piece of middleware that sits on the HTTP server and will give you a visual representation of your schema because you're producing a schema, which looks like this, right? So we have, this is the outputted kind of consolidated thing. We have a bunch of types and, we have a bunch of fields on a type and a field of a type. Somewhere in here, there'll be some queries that says where we can put things. So this is the SDL of our thing. Now this here is just part of Apollo server, and a lot of people have taken this on. This used to be called it doesn't matter. A lot of people have taken this into their projects and kind of refined this query service, if you will. And this is just a kind of developer tool, if you will, that you can choose to publish with your API or not, but it comes as part of most of the big packages. Whereas this one is one that you add on as middleware. Again, it's reading the SDL as well, just putting it in a visual way. Both are good. This one just lets you view it, whereas the playground will let you actually write a query. And because we're working against a type system, we get some IntelliSense and some knowledge about the thing. So when I'm kind of bouncing around, you'll see it will come up with, if I could say, events, all, and I can run it. It's probably an error because I need some more stuff. But this is a good point. So what I've done here is I've formulated a query and I've sent that across the wire as what ends up being a post. And in this case, I got an error back, and an error inside of graphs land isn't your typical HTTP, 500, 400, 2, oh, you wouldn't have a 200. You wouldn't necessarily throw back, a hard HTTP error. You're going to, in this case, the error is really that of you used me wrong. So all has, and it can tell you based upon the schema what you were, it can at least try to infer what you meant to do. And in this case, all doesn't have, we're not actually querying for anything. So if I add ID, now I'm getting back a payload that has all the different event IDs that are in our system. So, so this point is a critical one right here, because what we're doing as a consumer is saying how I want my payload shaped. I don't have to take on everything that may come back in a REST scenario, right? I'm saying, so this is really nice in the mobile side of things, because now if all I needed was name, I can get back an array of all the different named events that we have, and I wouldn't have to kind of query any deeper in the stack. Now, having said that, if we have a situation where you have some recursion, so let's say an event has a session, and this is a true scenario, and then a session has a speaker, right? Because that sessions have speakers. But on the flip side of that, speakers as a type, they also have a session, right? And so we'll just play with IDs for the moment. So now now in our system, not everybody's actually going to have one of those, but or at least have a session. So now what I've introduced is the consumer, right? or I'm sorry, I, the publisher, I'm not forcing people to necessarily call me a certain way. What I'm trying to do is give them a business model that they can work against and set some kind of guardrails up. But I can't stop stupid from happening, in the sense that it's completely valid in our scenario to have sessions, to have speakers, but then speakers to have sessions. So now I, as the API developers, needs to take into account that this, at a large data set level, may be querying for the same thing multiple times, and then account for kind of how to deal with that, such that I'm not just adding millions of calls to the database. Anthony asks, does Voyager work with its own APIs, with open APIs? Yes, you just pointed at a graph endpoint. You would have to do some shimming, if you will, to host it, but you can, in fact, if you went to the Voyager site, their GitHub page, they actually use GitHub and a few others, so you could totally do it. In fact, in the middleware, what you're doing is you're pointing it at where your graph endpoint is hosted. So for us, view internally, it's just pointed back to API.dat.tech. Let's see, where was I at? Okay, so not bad, right? The point of graph is to give people this type system, this schema that they can work against, and kind of open up creative ways to use that. We got any other questions? Trying to stay on top of the right side of the screen.
Yeah, if anybody wants to hop on, they can just ask a question. We can give you the mic, basically. Just let us know.
So from that conference side of things, from the back end side of things, right? These how would this affect lazy loading on the back? Great question. Okay, Emma. So Emma asks two related questions. I assume it'll only load if it's asked for in the query. How would this affect lazy loading on the back? It will only return what you have requested. Now, having said that, that doesn't mean that you didn't go through and query. You didn't end up querying your database for all the things. So let me explain with a bit of code. So we have, let me just pull open a few things so we can open to the side. Okay. So at our most basic, right, we have on here on the right, which doesn't make any sense. It should be on the left, but I put it on the right. At our most basic, we've defined a query, type query, and we've said that the query's name is hello, and it's going to return a string, okay? For that to execute, what ends up happening in a graph framework is you're going to take your schema definition, and you're going to take a whole bunch of functions. I'll speak in JavaScript terms because that's the land I play in the most. So what we're going to do is we're going to just start magically mapping things to one another, or the framework will. So Apollo or GraphQL Yoga or any one of these graph frameworks, what they are is they're just this wrapper on top of the GraphQL. Like Apollo is the wrapper on top of the GraphQL implementation by Facebook. And it's giving you plumbing so that you don't have to do a lot of this work. You can define it as a string, and then they make like the JavaScript equivalent of it. So you're going to start just kind of lining up these things, or the framework will. So you have a query that's called hello, and somewhere there needs to be a function that gets executed that will return whatever that query is defined that needs to be returned. So in this case, here is our function that's going to get called. Every graph function has 4 arguments. We'll come back to that. And in this case, I'm returning world. So to answer the question is, now how you choose to resolve this, nothing's changed, right? Like this is kind of we've gone through some front doors. It's time to go get some data. At this point, you can do whatever you need to do for whatever framework that, that you're playing with, for whatever database that you need to do, or that you need to work with in the way that works best for you. These resolvers are going to get chained together based upon how the schema looks. So if it's hierarchical, right, you're gonna have to call from the parent, and it's gonna work itself down, and it's gonna resolve those along the way. So you need to be cognizant of the fact that you need to be cognizant of the fact of how those things are composed, if you will. So now to get to the point about how do I kind of load certain things, every call has 4 arguments. Your root being the parent that may have called you. So again, if we're hierarchical and my parent returned and I'm dependent upon that, then I need to know what it is so that I could use it. The arguments that were defined, in our case, hello didn't have any arguments, but it would have been, you know, of type string if we had something. I can't even type. We don't have any arguments. Context, this is the thing, this is like your call context. So this is like your database connections or your user IDs, or really whatever you want to put in per call. And then the AST is the call itself, if you will. So the fields that were asked for in a bunch of context around the graph call itself. So Emma, to your point, like I could then use part of the AST to say, I only want to get a portion of these things. I don't want to go like select star and grab all things. I could look at my AST, grab what I needed to do, be selective about that, and then compose, you know, your Mongo query or whatever you wanted to do and select the pieces that you want. I understand the appeal for graph is the ability to shape your payload and simplify. So I think there's appeal on, I think you have to, Robert, I think you have to break the things up into 2 different sides, right? Because I think the appeal for the server side person, right, the API versus the client are a bit different in the sense that for me as the API developer, right, if I'm modeling TC here and I know that events and members and they have venues and rooms, and this is just kind of like how we think about the data, if you will. I don't have to, right? I'm going to make all these relationships and how things work. And then I kind of get to step back and you get to choose how you get to use me. So if I've modeled myself correctly, and by modeling, I also mean like it's, you know, you're fulfilling it, right? If it's just a schema and there's no resolvers, then it's not really going to get you much. But if I've modeled myself correctly, then we're not having a conversation about, I need another REST endpoint that does this. I need another REST endpoint that does that. You can just work against the API the way you need to. Now you on the client side, now you have this declarative thing where you can do things like make sure that the types are right. You can introspect it. So you can build out dynamic queries or dynamic forms and queries, because you can say, what's available to me to do that. And you get a much richer set that you can compose for whatever makes sense for that given component or call or set of calls. And then it's very common to work with a cache. So because this is a type system, now we have the ability to put a cache on it that we can invalidate because we know the IDs and the types, so we can add and take out of the cache easily and be smarter about that. Yeah, we'll do a simple one. So I hope that answers, Robert, a bit of it. It's kind of, yes, you get to shape the payload, but there's a lot of niceties in having a type system and being able to work against it, whatnot. So now I've just been showing queries. There's another flip side of this, which is the mutations. Queries being, getting data, mutating, changing it. So creating, editing, deleting, whatever. So the two things, they inherently work exactly the same. The query structure and everything that's around that is exactly the same. It's just how you define the payload that's going to go across. Simple. I'll go as simple as we can go. And this is, you can find all of this on this thing is going to be popping up all night. This is as simple as you could possibly get if you're in the kind of node, and this isn't even using Apollo. This is just straight up graph. So, whoa, don't want to look at that. Whoops, I just got into all kinds of trouble. Okay. So node side graph, I need a few things to make an API, right? I need to host an HTTP endpoint such that you can make a call against it. From a graph side, I'm going to need to catch that endpoint, right? I need to route whatever kind of path to myself. I need to define that schema, and then I need to resolve it and ultimately return it. So ignoring some of this top goo, basically I have express. I'm assuming that's large enough that you can see it. Whoa. I have express. There is an express GraphQL handler, so we don't have to use the handler ourselves. And so in this case, because I'm just using the native Facebook framework, I can't just write my string definition like you just saw a little bit before. I need to use the right JavaScript types. So I've imported them. And so my schema, this is as simple as the schema can get. Yes, all the stuff I'm showing is open source. So I can give you a link. One of them's at that conference and the other one's at Hello Unspecified. Those are the two project roots. So, and we can get all the direct links to you. So my schema, well, let's get back to the schema for a second. So here's Express. Express is going to be the thing that's going to listen on the endpoint, right? So we're going to listen on root. I need to tell root, I got to give it what its handler is. In this case, it's going to be that graph HTTP handler that we imported. I need to tell the handler, what schema to that it needs to work against. And then I got to listen, right? So now I'm going to fire open on that port and it's going to start listening for traffic. You can ignore some of this. This is just kind of CLI stuff. Here I've defined a schema. So this is going to be a bit verbose because I'm not using like Apollo, which will take some of this out of it. So this schema is, my root is a graph schema. I've got an object called query. I've got a a name, this arbitrary name called root query type, and it has a field called hello, which is going to return a string, and then the resolver that makes it true. And this resolve is that function that we just showed before, root args context AST, and it's going to return world. So what ends up happening is the graph handler sees the query come through, it parses out the SDL query that comes in. It says, oh, here's my hello, and then I know to call this function. If so, boom, call the function, return a data. If the data matches up, everything works. If it doesn't, it'll blow up. Like if you try to return an int, but it was a string, it would ultimately fail because you were supposed to return a string. Now, that's as simple as it gets if you use the raw stuff. If we take it one step further and we say, let's use a framework to do it, then so now we're pulling in Apollo server, and instead of having like the graph object type and whatnot, now we're able to define, where did my schema go? Right here. Now I'm able to define my schema as a string. In this case, it's called GQL. So we're going to use a, oh, I forget what it's called. Templatized string. I think that's what that's called. But we're going to pass the string in. It's going to turn it into, the proper object structure that, Facebook GraphQL would expect. And then here is my resolver. That's the thing that's going to fulfill that query. And because hello and hello match, it's cool. And then in Apollo land, again, you could pick other frameworks. They all essentially work the same. We're going to, when we create the Apollo server, we got to give it the type definitions and the resolvers. It'll do the matching for us. And then we hand that off to Express, and then Express does it. So Anthony, to answer your question, yeah, it's whatever you want it to be. Like you are defining your schema, and all of what you see here is us just creating types. Let's go back to the query. Is us, I'm leaving it small on purpose, but us creating a bunch of types that relate to other types and return things. And at the end, it's kind of arbitrary what this really means, because these things here is a type and there's a function to fulfill it. And this for me is like the aha moment. I think that people don't necessarily, it takes them a little while to get to. It's a schema and a bunch of functions, and they all got to line up. And as long as they're kind of returning down the stack, you can make whatever hierarchy you want. To the point of like, I don't have to, let's say I'm here. Whoa, so sensitive. Trying to get a little bigger. Okay. So let's pretend event is SpongeBob. Now you could see I have a bunch of other references, sessions, partners, notifications, milestones, venues, like those are subtypes. And in sub cases, they're other things. So I don't have to just have a resolver that resolves the event. I can have a resolver that resolves the event. And then on the event, I can have more resolvers that resolve each one of these particular pieces in the way that makes sense for them. And as long as they're returning back what they're assigned to return back, then the whole thing gets composed and the payload gets sent back. And so if you step back again and you think about this model that we're giving out to our customers to use, again, you can fulfill it however you need to, wherever that data may exist, or cache or anything kind of on the backside, as long, and it will be your like, I don't know what the best way to put it is, like, it's just this call orchestrator. And because it's all promise-based, your hierarchy, if there's things that are parallel, like start date and end date, and let's say these both, for whatever silly reason, they called out to some other REST endpoint, they'd fire at the same time. And once they're resolved and then return back up the structure, the whole thing's just going to kind of return back up. So I see Anthony had an aha moment. So that makes me feel like I feel a little good. We had a moment. But I think that's like, for me, that's if y'all just take anything out of this, just take two things. You got to make a data model. I'm sorry, I don't want to use that word. You need to make an API model that your customers are going to use, that you feel good about, and you're going to, it's a contract. So no different than you buy a house or you do some consulting work or whatever, it's a contract. It's a contract back to the people who are going to call you. The better you model it, the easier it is for them and for you to kind of carry it forward. On the backside of this, it's just a bunch of functions that resolves data. Like there's no magic in it. There's no, hidden like alternative meaning. It's take the schema, match it to some functions, return some data around. And that's really, in its simplicity, that's what it is. Now, you can do sockets and, long polling and all the other web type, API stuff you want to do with it, but they're still just dealing with schema and functions that do a thing. Let's see. Other questions? Taking a break so I can drink some bubbly. Not sponsored by bubbly either. So you can call the object anything. Yes. Is a project. Okay. We'll just get to that real quick. If you go to GitHub, and Hello Unspecified is my company's landing page, if you will. There's Learn GraphQL. This is a project. This is the course that I'm putting together. All of these, those little bits that I was showing you is in the server side. Again, this is a work in progress, but this tries to walk you through start to finish each one of these different things. And hopefully in a few months it gets released and whatnot. On the TC side, so that conference, all the stuff is out there. So here's the that.us website, here's thatconference.com. Each one of these that API is our microservice that sits back there, and that actually looks a bit like this. When would you need to implement Apollo? That's a great question. Here's why. Here's a good place. So let's talk about a little bit of, we're not showing all the codes at the moment, but let's talk a little bit about kind of the TC kind of infrastructure stuff. We are on the front end of things, right? We are trying to get, okay, that's a awkward step. Can't go like 110, 150. Okay. We are mobile apps. We're that.us, we're thatconference.com. We have some assign thing, we have some IoT stuff. Like these are all of our front ends. They all move independently of one another. They all have different life cycles. They're different open source efforts. Depending on the rhythm of where we're at and who's working on them, they could be going bananas. They could be completely dormant. Our graph endpoint. So now we're gonna take it. We're gonna go just all the way bonkers with things. We're a federated graph. And so what that means is we're going to take our different logical parts, in this case, members, events, sessions, and partners, and we're going to deploy them differently. And in our case, ours gets deployed to GCP. It gets deployed to Cloud Run. There's serverless Node 14 containers that each run independently of one another. Partners doesn't know anything about sessions, doesn't know anything about events, doesn't know anything about members. The schema, our graph schema does. And our gateway is the thing that composes a schema from each one of these different parts and puts them together. So Anthony, to your point, when do you want to implement Apollo? Well, Apollo is a fantastic framework. There are others that are around it. They seem to be doing just bonkers work on it. It's a good group of folks. They take a lot of the kind of ugly plumbing, if you will, and just abstract it away. So you don't have to mess with it. But they're also pushing spaces like Federation, which Facebook's defined the spec, and Apollo and others, have participated in it. But they've come to say, okay, well, if we want to have a federated graph, then we're kind of the place to go to, or we're the framework that knows how to take all these different things. And there's other efforts as well. IBM's got some stuff, and a few other folks, but they'll do all the plumbing here to say, oh, so now you have a gateway, and this is for us, this is another set of serverless endpoints, and we know how to compose it and work with it. And so now if you think of that same, like, take your schema, just resolve these things, now we're going to split that call up against 4 different backends. And those backends are going to resolve however they need to resolve. And the gateway, if I was an event and I need to pass sessions, which you saw us do that query, the event returns and then tells the sessions, like, go fulfill these sessions, or the gateway says, hey, sessions, I need to go get these sessions. And that's all kind of all orchestrated by the gateway. And so Apollo makes that really easy to use. Again, it's a fantastic framework. Starting raw is cool, but getting stuff done quick is even cooler. And in this case, we have REST endpoints. So because we're federated, somebody was asking, like, when to use one versus the other. Like, we do things like file upload. So your image that's part of your speaker profile, well, to kind of move that across the internet and where it needs to go, if that was part of a member's record, right, I would have to take that image, I would have to buffer it, I'd have to rebuffer it down to stream it back to members, to ultimately dump it into a bucket somewhere. That's just a lot easier to do with REST. So we've just composed our kind of API structure such that, when you're graph, you're over here, when you're REST, you're over there, 98% graph and 2% REST. Now, you can hide your REST stuff behind your graph stuff as well. And that's a very common pattern, is to build a schema that represents your business and then just orchestrate REST calls because you had existing legacy stuff that you needed to deal with. But now you can kind of just hide them, if you will, and work with them as a REST endpoint behind the scenes, and then a graph endpoint up front. So different way to handle it. All right, so we answered the question about that. So new endpoint works with a REST endpoint. So the new endpoint works with the REST endpoint. If I think I understand your question right, it would be that your graph, right, you would essentially say, instead of this like returning string, whoop, get out of my face, right, returning string, you're just making a REST call. And there are some tools in Apollo, is one in particular, that has like a data structure or a way to facilitate that call such that it's resolved on time and can be cached and whatnot. So instead of you like calling your database, you just make an HTTP call. I think that answers your question. Or I think that's the question you were asking. That's a better way to say it. Does that kind of make, I mean, I know there's a lot of people on and I've been speaking kind of fast. Does that help kind of clarify the API side, what it is, why it is? I just want to dispel the complexity around it, because there's just you know, it's not, it doesn't need to feel like it's super hard, because at its core, it's really not. Not that you can't do complicated things, but it doesn't need to be made hard. So let's talk about the schema a little bit. I'm going to pull open I'm going to pull open a new window. Do I have any of this open? No. All right, let me, I want to show what we can do with this schema. Do you have an example using Open API? Like open, you mean that Open Graph API? Let's go to member. All right. So let me find some code real quick. Yeah, we can look for something. I want to show off a It would take me a second to find it. Oh, it would be a mutation. I'm sorry. Data types, mutation. Okay. All right. So because it's a schema, or because it's this schema language, we have this ability to decorate it. And so the first place that we can decorate it is with documentation. So you can see here, I got some quotes around this. If I head back over to the browser and we go into docs, now this is being generated from my schema, and we go to members, member, actually me. You can see up here, we've got some documentation right up here on top. That's stuff that we wrote. Haven't done real good through here. Actually, if we click on one of these, did we get it? No, let's find one. It's just talking about the type being returned. Yeah, here we go. So profile links has our documentation as to what it is, or what we've defined it as in English. And then the type that it returns and what they return. And you could just kind of keep crawling this. So to just keep walking the stack. This is the that conference API, which is open. Y'all can look at it, play with it. So we have this ability to decorate it. So that's a documentation perspective, but we can also decorate it as to how it works. So in this case, what we've done is we've written what's called a directive. And a directive is something that fires before the resolver fires. So in the chain of things that happen, again, we're just composing functions to get called. And in this case, before this member mutation fires, auth is going to fire. And we're passing it an argument. Again, it's just another resolver, but it's a resolver that we've defined that we can use as part of it's a resolver that you can decorate things with that will fire before your implementation fires. So they're meant to be kind of cross-cutting, if you will, across any field, any type, depending upon how you've written your directive. So you can attach directives to different parts of the types of schema that you have. So in this case, what we've done is auth. This is our auth. And if you think of, token comes in off the API, we need to validate it against auth 0. We're going to make sure that they have the right roles so that they're doing the things that they said they can do or what they're asking to get done. This would fire, that resolver would fire. And if they pass the check, then we would just continue down further in the chain. If they did not pass the check, then we would return an error back to the user. And that's, I bring that up because being able to, one, it's super clear as to, what's happening where and how we're, like in this case, how we're going to require something, but it's a way for us to kind of bend that schema around so that it works a little bit better for us, or better, like we can put logic in places that it can be reused easier. Anthony says, let's play with an open API. Sure, let's go to, we can do this. Let's go to, we go find GraphQL Voyager because they've already got a demo playground. They used to have one. They still have one. Change schema. Let's go to GitHub. Let's see, we need, let's go to GitHub's. Actually, I might have it in that keynote already. Let's see if I got the URL. Pull this over here. No, I don't have it. Are you, some of these require you to have, some of these require you to have an account set up. So let's see if we can find something quick outside of my own. Run in the Explorer. Yeah, here we go. Let's see. Will this get us there? Yeah, yeah, let me find it first. Let's make sure I can actually do what I say I'm going to do. Authorize. Ah, crap. Hold on, please. Need to get fancy. GitHub. All right. Not even totally sure what trouble I could get into. What's that?
Just want to let you know, there's I've played around with the SpaceX GraphQL API. It's public if you don't want to deal with user accounts and tokens.
SpaceX?
If you're interested, yeah, I can send that over.
I'm sure the Googles can get me there pretty quick. Hold on, SpaceX Graph. Of course, they use land. Yeah, there you go. Wow, there's nice and fast. They have more servers than I do. Yeah, here you go. I think the thing, Anthony, I think the thing maybe is, I'm trying to get this window out of my way. At the pub, like the endpoints don't really matter. Be the best way to do this. Like, I think what you're really asking is like, ultimately is like, hey, I need to make a call. What does that look like? And so if I was to put this doc, right? And so I go to, public endpoint, in our case, API to that tech, and I want to know, or SpaceX, and I want to know how to query against it. I'm going to come look at their docs, right, that are generated from the STL. So here's the event query, or here's a set of queries. In my case, we're going to take events. So this is graph, right? Define query, and then here's events. So I'm going to query events, and then on events it returns, in this case, all event or event by slug. So I'm going to go all. I'm going to go down another step, and then event. It's in this case, it's kind of the final resting point, if you will. We're a very hierarchical graph implementation. But here, an event returns an ID, a name, a slug, a slogan, right? So we kind of move this over a little bit. Get back out of my, come on, right? So all, we said, we said ID, and you can see because we have this, because we have a type system, right? We can get the name, we can get the, in our case, a session. Now a session is another type, is another resolver, in this case, another microservice that will return stuff. And then if I run that, right, this, what ultimately ends up happening is, I don't know how big this is going to be. Whoa. Where's, right, here's our call, and here's our request, and here is the payload that's getting posted, and you're going to see there's a bunch of carriage returns in here, but event, your query, events, all ID, name, session, query, events, all ID, name, session. That's the post that's getting sent over the wire. So there's no crazy voodoo in there, or no crazy magic. And then this is the payload that gets returned, data, which is a standard thing. Here's our events. It's going to match what we've queried. So events, all, here's all. All is an array of things. So the array, ID, name, sessions. Not all these have sessions, this one does. And we can even do things, since we're in control of the payload, we can do things like, let's get this out so we get a little less data. Okay, we could do things like, maybe I want to call this event name. Oops. Name as event name. Did that right? I did it backwards. Event name as name. It's really hard to do with this. Okay, so now I've actually changed the way the payload looks, even though the schema said something else, right? I could call this UID. Maybe I had, maybe I'm trying to kind of bend this into an existing front end or client or whatnot that needs to, I don't want to change however it's decomposing its data into the UI. So, so you can do kind of fun little things like that. If I was to show, if I was to go a little different direction, now this is that.us. Here is us, or here is myself, if you will. We've got a bunch of, well, here we have a bunch of collection of queries, if you will. We're just extracting away the API calls. So submissions, sessions, here's a bunch of graph queries. Here's a mutation. This is an arbitrary name. We're going to take some variables. Session, we're going to update, and we're going to update an open space, and we're going to pass some fields, and we're going to pass a variable, down as to how it gets called. We've got a graph client that this happens to be a Svelte graph client. We're just calling mutation. This is just a wrapper around doing that post. We're going to tell it what query we want to query or mutation we want to run. We're going to give it the variables. And in this case, we have to call toPromise so that we get a promise back. And then once we get it back, we can check to see, was there any errors? And then if there's not, now you'll see that same structure again. There's, in this case, it's data sessions update, because that's the stack. And what we do is we just kind of decompose it down a little bit smaller so that the only thing that's being worked with is kind of the end result. Syntax of arguments, absolutely. Arguments, we'll stay in this. So let's start with the definition. So if I wanted to add an argument, so this is hello world. So if I wanted to add an argument with to my schema, it's like you would think. I'm going to give it a name, whatever. I don't know, Nico. I'm gonna call it Nico, and Nico's going to be a string. Andrew, it's not doing that. Graph has no bearing on, you literally insert your DB magic here, and you would just return it. There's nothing, there are what did I heard a great term the other day. There are frameworks like Prismic and Keystone and another one, there's a few of them, that will go up one level above Apollo, and they'll be define your schema, and they'll do all the underpinnings underneath. I'm not showing any of that. That's like another higher level opinion. Like if you're signing up for them, then you're signing up for how they choose to use the database and abstract it and all that. Good, bad, or indifferent. Like there's a place for those too. Or if you have resolvers in Java, then you just have those calls in your service or whatever. Yeah, exactly. Like whatever, it's whatever function is going to resolve your schema, call the database, however. And it doesn't even, I keep saying database, but I'll also note that could be a message bus, that could be a REST endpoint, that could be, an in-memory cache. I think GraphQL unfortunately gets mixed up with graph database a lot, or that because it has the word query in it, it's somehow it carries forward the predicates that you would get from a database, and that's not the case. It's a spec that allows you to query against the schema that you've built. So back to the arguments. So here's hello. This is our query. We've got a named argument called Nico. It's a string. If I added a bang symbol, that would mean it's required. If I said it was an array, now it's an array of strings that are required. And by required on this end, it means you have to pass it back. If I went this way and I said my return is required, that means I, the server, have to return you a string. I don't get a choice. So if I was to return null, it would blow up. So that contract kind of works both ways. More interestingly, if we were to here, like that's all fine and dandy, but if you think of that.us, let's give real stuff. So, you know, we have the ability to go to do this. So this main panel here in the middle, if we say events, that online, this was an event that we just had a couple of weeks back, a virtual event. Now, inside of this, this is its own event ID. If you're thinking about our domain model, this is its own event ID. It's event ID that has its own sessions, right? And so here are all the sessions that happened with that. So this is one query. And then if I go back to just the main board that you can put stuff on any day of the week, any hour of the day, this is a different event. It's the same query. I don't know why it's taking so long at the moment. It's the same query. There's only 3 things on the board at the moment, but basically what we're doing is we're swapping out event IDs on that same query. So I say that because we were talking about arguments. So here, when I define my query, what I want to do is I want to have a dynamic argument, dynamic. I think I'm saying that right. Dynamic argument doesn't sound right. It's been a long day. I want to have a dynamic argument, meaning we're going to pass that argument in at the time that we know what it is. But in my query, since my query is a string, then we need to define it in the query, but we don't know what it is yet, right? So I can't say like event ID equals 1, 2, 3, 4, because I don't know what it is yet. Or it wouldn't be here, it would be here. It would be 1, 2, 3, 4. But I don't know what that is yet to pass down. So what we do is we put a variable in place. So when we define our query, we have this $name, and then we tell it what type it is. In this case, it's an ID. And an ID in Graph's world is a unique identifier that you can take to the bank and know that it is, without question, going to be unique in all sorts. So, so we're saying we're going to give it an event ID. We're defining that a query, and then down lower we can use that variable in this query. And so when we call it, when we do a REST call, query mutation, well, I guess it's a query, right? Now we're not there, here. This, go one step smaller. This here is our API call. So that panel, that main panel, calls query sessions. It passes the event ID that's contextually for wherever you're at in the UI, right? We call, this happens to be abstracted a little bit. So we're calling client, the graph client query. We're passing it the query itself, what we just looked at, and the variables. And in this case, any headers or whatnot. And it'll just formulate that payload and then pass it along. So arguments are really as simple as that. I think probably a little harder is dealing with the client, in the sense that you typically have one client for your API. And so if you're kind of mutating the client, whether it's changing headers or dealing with the cache, these are all kind of make the UI faster. and stop the calls from happening a bunch, then that's a very important piece that needs not be overlooked. For example, let me give an example. If I was to say that this UI right now, it can kind of be in like 3 states. We can always call the network. We can do kind of a cache in a network. We can do a cache, so we can do offline things, whatnot, and then sync back up when things happen. Because we have this type system and these IDs and in this structure, it makes it easy to deal with the cache. So if I was going to come up here to my submissions, and I got to pick one that's available at the moment, edit one of them, and I make a change to this, right? Whatever, I'm not going to change it, but let's say I made a change and I come down here and I update it. The end result is I've got to go call the server, run that update, and then somewhere else, right? Maybe back up here at the board, like this session needs to get updated. So now's where some magic happens. Because we already know the session ID and we already know what we wrote, we don't actually need to call back and go get that data again. Like we just sent it. There's no need to like go query again, unless like the business for some reason, maybe something else changes the result of it, and then it would kind of invalidate itself. But you can optimistically update your cache. So when the mutation gets fired, you can say, cool, well, I know that data, I'll just update the cache, and then whoever else is bound to it gets updated automatically, and you don't need to requery again. So there's some kind of cool stuff you can do there. So Shai, I hope that answers your question. Emma, if you have a repository in Java, yep, I think we covered that. DB calls, not a big deal. Let's see. No, Nico, you're still on. Can you think of other? Let's see, what time is it? 7:30. All right. So if there's questions, drop them in for sure.
Yeah.
We got, what, 30 minutes left, or?
I mean, I guess we can go as long as you would like to go, but we can definitely wrap it up sooner than later if you want to.
Yeah,
it's up to you.
It's up for the people.
It's up for the people.
I'm here for y'all.
Another thing we could do is whoever is still here, we could go through and people could just share who they are and what they appreciated to learn today, or if there's any other questions they have, just have them speak up and
yeah, for sure.
Talk about what they're learning and what they want to, if there's anything else. Yeah.
Can't seem to. Here, let's see my takeaway. Let's see if I was to put together some takeaways. There's four types of things you need to learn with graph. Right? We need to know what a query is. You need to know what a mutation is. Apparently, I don't know how to do any of that. There's this notion of a subscription. A subscription is a query that's on a socket. So same structure, same resolvers, same types. Instead of type mutation, it's type, I think, subscription. And it's a socket. And so whenever the server changes, client fires up, there's a persistent connection back to the server. And then whenever the server, that obviously means you're not running in serverless. Whenever the server decides to make a change, it can make a change and it can go update whatever clients are bound to something. Learning graph. I'm still trying to learn when and how to implement GraphQL. Well, let's get you over that. Let's talk about the when. The when is going to depend on, well, that's a business decision, I guess. At its core, if you're, for us, we we're in control of our destiny in the sense that like our infrastructure is our infrastructure, right? I'm in control of all these servers and my clients. We do some partnerships with others who use our client, but they're all right with using Graph. Graph's been around now for 8 years. So it's not like it's, you know, just new hot sauce that people aren't there. There's pretty much a client in, I don't know, most languages. I don't know that, I'm sure there's not a client in every language. You don't necessarily need a client. You could just make an HTTP call and post it. You lose all the benefits of like the Apollo client or some of the others. So the when piece is, I guess, when does it work, you know, for your clients? You said you're using React. React has a Relay client that's from Facebook, and then Apollo has a giant React client, which is really great, and it uses hooks and has its own cache, and they're very active on the React client, and it's also React native. Obviously, React and Apollo, or React and Graph came from Facebook, so they work well together. If you're on the server side, right, you need to start with really creating your schema. You need to understand like what you're modeling. You know, if you can't kind of draw a picture, if you will, of what your API looks like for somebody. I always think of this, I like showing Voyager because I think of like the whiteboard. If I was to go explain to somebody or explain to all of you, like, how do you interact with TC? How do you, like, how would you use us? I would start to draw this picture. And so, but that's our kind of business domain model. So if you can draw the picture, right, then the, you know, putting together the schema is just simply, you know, doing this kind of stuff, right? We're defining some types, and depending on the programming stack of choice, we're going to tell, in this case, it's Apollo. We're going to tell Apollo that these are, you know, here's our Apollo server, and here's our schema, and here's how the data sources that come on context. Here's some context where we're doing, you know, some Sentry stuff and whatever. But all of that's like, you know, just go check out. I don't need to tell you how to go read their docs. That's not going to give you, you know, they give you the schema basics. The Apollo documentation for the most part is pretty good. There's some places where it's lacking, but you can start here. You can start, I'll do it this way. You can go there. You can go graphql.org. This is the spec. One day you'll be able to go to graphql.help. You know, this walks through all the different parts. It's really not huge. It's a type system that you can extend. It knows how to call things. Once you kind of understand that, and then the rest of it's pretty easy. Yeah, here, the first thing, you model your business domain as a graph. I agree. I never even read that. Now, I know REST was mentioned, but now that I see RPC up here, I think an interesting question, completely off, not really off topic, but something to think about, which kind of is the new and shiny, is gRPC. So, you know, where does Graph and gRPC kind of, and REST, you know, how do they all kind of play together in this world? Because there's certainly some niceties with RPC too. I think I saw, thought I saw some questions, but I can't find my Zoom window anymore while I'm looking at it. What is gRPC? Let me get you, copy that off. I'll give you all of the little demos here, right there, here. Good one with demo project, use all the parts fit together, including job site. Nice, thanks, Emma. And this, and at this Learn GraphQL, like I try to step through things, granted it's still pretty new, but I guess server that holds information and is very efficient at dealing with queries. No, Graph wouldn't be the server that holds the information. Graph would be the mechanism to move information, to be queried and move it. So Graph itself isn't a server, right? It plays inside of, if it's Node, it's Express. If it's Java, I'm sure Emma knows. It's gonna run inside of your HTTP server, and it's going to know how to deal with your HTTP endpoint, and it's going to know how to go based upon the schema that you've defined. It's gonna help facilitate making those calls. It's as if, and the efficiency piece is, it's as efficient as you will let it be, meaning because somebody can come over here, like what if, right now we have, I don't know, 10 events, right? So, but I'm not, like, my query is all. What if that was hundreds of thousands of events, right? Obviously that would be a disaster to not only pass across the wire, but to call against the database. So then I would introduce something like paging. So we would call, we'd get 10. In fact, just show a live example. If you go to dat.us and you go to members, this right here, these cards, these are all the people who have said, hey, you know, we want to be part of this. This is one query. And what happens is this query is going to go and get 25 or 50, maybe it's 50 members, and it's going to pass back a cursor. And when I scroll to that, I'm going to get another loading, boom. It's making another graph call, and it's going to pass that cursor back. It's the same, it seems to be taking forever. It's going to pass the cursor that it got back. I think this thing just died. Oh no, there it goes. So we called, we got 50. Along with the 50 came a cursor. When we go and call again, we're going to pass that cursor back. We're going to get another 50. And we just kind of keep repeating that until we get to the end. So even though like efficiency is great, but when you start to really model your model things, right? We made an explicit choice that all was a good thing to do. Now we don't have a lot of events, so it's fine. But you know, if we start getting into the 25, 50, then you know, now it's time to start thinking about things like paging and maybe other caching means, you know, whether that's Redis or something else. Again, depends on your infrastructure in the back end. What else? Other questions? Let's see, I was putting together some links. Apollo. Do you send out Jacob, do you send out like a wrap-up email?
Yeah. Yep. So if
Okay,
you register
I'll
for this event, yep, and we'll share it through our meetup group too and all that stuff. So
okay,
yep.
I'll just put it together later and send it, and then we can blast everybody with the links.
Yeah, sounds good.
Is paging built into GraphQL or you need to implement? I believe it is part of. It's a great question. Let's go look. I believe it's part of the spec. Pretty sure. No. It's not in the sense that it is part of Apollo, though. Where's paging? Okay, so that's a great question, Emma. So it's not in the sense that it's just arguments that you're passing back and forth, right? Because obviously paging is very sensitive to your database implementation. We happen to use Firestore, or at least we use Firestore for part of it. And then it's also dependent upon your client side, right? Because you have to handle a cursor and what you're going to do with that. Apollo has a mechanism kind of built into their framework. I think it was Anthony earlier. It's like, when would you use Apollo? That kind of bolts that on a bit to their client and to their hooks in React, so that you can set the offsets and the limits and things. They have a way where you can like calling fetch more. This is what it's called on their hook, where you define all that, and then when you get to that kind of like we were in the scrolling, and you need to go get more, you can recall it, and it passes along. So they've done a nice job of kind of trying to make that stuff easy. In the Svelte land, I handle it myself. We just pass it back and forth. But again, the Apollo documentation is by far really good stuff. If one has not seen light, we're going to get you to see this light, Shai. We want to understand graph through a REST lens. Would it be like query, get, mutation, post, subscription? It would be like, okay. So I'm not using my vanity URL at the moment, but these gateway calls. So REST, when you make a REST call, it was actually mentioned earlier, and I kind of glossed over, and I didn't mean to. I was talking about the JSON spec, or JSON, was it API? No, it's JSON spec. So REST, right? If you query, it's a get. You make a change, it's a put or a post, a delete. So you're using the verbs to declare intent. And I mean, you could do really bad things, right? You could do it all over again if you really wanted to, but you're using those verbs to declare intent. You're going to pass a payload, and you're going to get back a payload. But the only way that you know about that payload is that you and the other person, or you and you, whatever, made an agreement that the JSON that's getting sent back and forth, if that's what you're using, could be XML, you agree upon and you understand, right? There's no like hard contract to that. Graph is still REST, but you have a contract that's the payload that's getting sent. So we're not going to get concerned about gets, posts, puts, deletes. We're just posting, and we don't even, I mean, you could do it manually if you wanted to, but here's a post to our server. This is going to get members down here. So get all members. This is the query. This is the payload that we're posting to the Express server. And the Express server is going to pick up that post, and it's going to parse this payload, and then it's going to start firing off these. It's going to validate it and make sure that it's a valid payload that can get sent across. And Emma, you asked about paging. There's the page. It's the variables that's getting passed on. So we're going to make a post. Our post is going to have a payload. That payload is going to be the graph query and any variables, whatnot. And then that's going to go just like a normal REST post would happen. But then on the API side, some framework is going to pick up that call, right? And it's going to parse the payload. And in this case, the payload is a graph payload. It's going to parse that. And then it's going to, because it's graph, it's going to do some schema validation and make sure that it's all valid and everything is cool. And if it is, then it's going to start calling resolvers. And then they'll fire off and go get the data that they need to, and then it's going to return it. So, and then the subscription is in fact a socket. So it's, again, it's all kind of the same thing. That just happens to be over WSS. So I hope I just got you the aha moment. So graph is technically always a post. It is, although you can do a get on a query, but that's, nobody really does that unless it's a firewall problem. So, and this is that post. So here's your method post. Here's the Express server. You can see I'm just posting JSON across. And this is the payload that I'm posting through. Whoops, that's gross. Right, and then my response back is just like we were messing around with in the browser. Here's my array of data. So graph is just this thing kind of working inside, the REST bounds. But what we've done is we've said, here's a contract, here's a payload. I'm sorry, here's a contract that we're gonna adhere to. And then we've got some tooling on both sides that does the validation and make sure that we're kind of doing the right thing and whatnot. So good, I'm glad you got there. Other questions? Going once, twice, 3 times. All right.
Cool. I think, I think we can start wrapping it up. This is awesome.
I will put together a bunch of link vomit and I'll send it to you, Jacob. And
sounds good.
You can send it along to everybody. We'll try to point back to all the things that we talked about. And whatnot. So graph is sitting on top of Express. Express is doing the get post, but just the payload off the graph. I probably would have said it the other way. Apollo is just middleware in Express. So if you know Express, Apollo is just middleware. And it's handling a route. And yes, Express is doing all the hard work, all the hard HTTP work, which is really just Node doing all the HTTP work. So you would have Node, Express, I guess you'd start bottom up, Node, Express, Graph. I can give you an example of a subscription. Yeah. Let me move this back over. Let's do it this way. It is signs. Not that one. I don't have this code pulled down, but I can at least show what it looks like. So I wasn't lying when I said, there's kind of two sides with, who is this? Julian? There you go, Julian, there's a link. This is a little older code, but here is our subscription. And the thing about a subscription that makes it just a slightly different than a typical resolver is that we want to iterate over everybody who we're connected to, and we may or may not want to send them information back. So we wrap ourselves in an iterator. And so in this case, there's an HOC. So the subscribe is the resolver for the subscription. We have this iterator. Here's our values that are getting passed down from the resolver. This pub sub async iterator is listening for in this case, it's an event emitter. So when this event gets thrown, this gets picked up, and then we can make some decisions about whether or not we want to send the things back and forth. So it is more complicated than a typical resolver because you're on WSS. You kind of have a different, like if you're in authentication and you're needing to validate who can call you, you have a different kind of entry point into Express, and you need to make sure there's a bunch of lifecycle methods. This is where Apollo really shines, is because they give you these hooks so that you can, because you would only get connected to once and then reconnect if something failed. So you can connect through, you can do whatever validation you have on that first connection, and then you can loop through these things and make a decision whether or not you need to send the payload back to them and map up however you decide to map up. So I'll put some pointers to the follow-up in that. Sockets are they're pretty cool and amazing, but if you're getting into multiple servers and scaling out, then you've got to deal with that, kind of handle that as well. Now you got a message bus involved, and you got all kinds of other complexities.
Well, awesome. I think we can wrap it up. It's almost 8 o'clock. I think we got a lot of great questions answered today. So thanks for joining us, Clark, and for sharing your expertise and experience and all that kind of stuff. And yeah,
thank you for everybody for taking the time out.
Yeah. Hopefully we'll have Clark back with us later this year or in 2021 to do it again. But of course, check out everything he's doing with that conference. Check out his Twitch. We'll send links to all that stuff. And Clark, is there anything else you want to share before we sign off?
No, thanks for the time. I mean, I'm available to kind of answer any questions. I'm out there. If you you want to send an email, I'm pretty bad at it. Sometimes I'm on Twitter, but come to that.us. It's open for everybody. Feel free to throw stuff on the board and whatever. If you need help,
awesome.
Let me know.
Yeah, we'll link to, like, when your course comes out, we can update folks on that as well. Especially people that went to this event specifically, but we'll also send it out in our newsletter, like, to let people know that it's out and available and all that stuff. So
sure.
Yeah, we appreciate it.
I'll get together a bunch of links and pointers to things, and
yeah,
I think there's enough people. It's not new in any regard. So if you're spinning your wheels, you're probably not asking the right question.
Got it. Yeah. Well, awesome. Well, thank you so much. We're going to sign off here. Thanks, everybody. Yeah, if you need anything, you can just reply to the email newsletter. It'll come back to me, and I can always connect you with Clark if you can't get a hold of him for some reason. We'll get you in touch. So